Imagine a ribbon, so long it stretches from Earth's surface into the blackness of space. Anchored near the equator, it climbs past clouds, plains and the atmosphere, reaching thousands of kilometers up to a counterweight in orbit. This is the space elevator, a permanent bridge between our world and the cosmos. Think of it as a vertical highway, not a building, but a road to the stars. Instead of explosive rockets, we'd use electric climbers, powered by sunlight or lasers, to ascend smoothly and quietly. The journey would take days, not minutes, but it would be gentle, carrying people and supplies to a station high above Earth. The top of this ribbon sits in geostationary orbit, about 36,000 kilometers up, where satellites match Earth's rotation and stay fixed over one spot. A counterweight further out keeps the ribbon taut, balanced between gravity pulling down and centrifugal force pushing up. It's a cosmic tug-of-war, with our ribbon as the rope. The space elevator is humanity's boldest dream of a physical link to space. It promises a future where reaching orbit is as routine as taking a train. No longer limited by rocket fuel, we'd have a peaceful, reliable, and affordable path to the stars. This ladder isn't built of wood or steel, but of imagination, science, and the strongest materials we can create. It's not magic, it's engineering at its most ambitious. A vision of a future where the cosmos is within our reach, the ultimate ladder to the heavens. Grand ideas like the space elevator begin in the imagination, not the lab. The concept was born in science fiction, where writers dreamed of towers to the moon and bridges across the void. In 1895, Russian scientist Konstantin Tsiolkovsky, inspired by the Eiffel Tower, imagined a structure reaching into space, a celestial castle at its peak. He realized the top would be in orbit, but the materials didn't exist. For decades, the idea remained a fantasy, overshadowed by the rise of rockets. Yet science fiction kept the dream alive, passing it from one imagination to another. Writers built worlds with words, inspiring generations to think bigger. The space elevator became a symbol of overcoming limits with ingenuity, not brute force. These stories ensured the vision endured, even when it seemed impossible. They inspired real scientists to ask, what if? The torch of imagination kept the dream burning. And so, the idea survived, waiting for science to catch up. The space elevator moved from fantasy to plausible engineering with a simple shift build from the top down, not the ground up. Instead of a tower, imagine a cable dropped from a satellite in geostationary orbit with one end lowered to Earth and the other extended into space as a counterweight. This skyhook would be held in tension, balanced between gravity and centrifugal force. In 1960, Russian engineer Yuri Artsutinov published the first modern concept of this tensile elevator. He showed how a cable could be lowered from orbit, sidestepping the impossible weight of a compression tower. In 1966, American scientists like John Isaacs independently explored the idea, calculating that a cable could reach Earth, if we could invent a material twice as strong as anything known. The dream now had numbers and a blueprint. The challenge shifted from imagination to material science. The concept was no longer just a story. It was a problem to solve. The space elevator became a tantalizing engineering puzzle. The question was no longer if, but how. And the race to find the right material had begun. The space elevator's journey was shaped by visionaries and scientists alike. Arthur C. Clarke's 1979 novel, The Fountains of Paradise, brought the idea to the world's attention, making the elevator feel real and inevitable. Clarke imagined the engineering, politics, and impact of building such a structure, inspiring millions. Meanwhile, American scientist Jerome Pearson independently detailed the physics and engineering in a landmark paper, calculating stresses and system dynamics. These pioneers, Tsiolkovsky, Artsutinov, Isaacs, Pearson, and Clarke, formed a chain of inspiration, each built on the last, refining the idea and sharing it with the world. They transformed a fantastical notion into a credible, if daunting, engineering challenge. Their work laid the scientific foundation for future generations. The space elevator became more than a dream. It became a goal. The vision was now in the hands of those ready to build. The skyhook was no longer just fiction, it was a blueprint for humanity's next leap. Why did scientists embrace the space elevator? Because rockets are hard. Escaping Earth's gravity requires massive, explosive machines and millions of kilograms of fuel. Expensive, risky, and inefficient. The elevator offered a way to cheat gravity, using electricity to lift cargo gently and cheaply. Costs could drop from tens of thousands of dollars per kilogram to just a few hundred. This would make building large structures in orbit, like solar power satellites and giant telescopes, feasible. We could assemble interplanetary ships in space, launching missions to Mars and beyond without fighting gravity. The elevator wasn't just a new way to reach orbit, it was a key to the entire solar system. It promised a shift from scarcity to abundance in space. Space could become a place to work, build, and live, not just visit. Access would be routine and affordable, opening space to science, industry, and eventually, everyone. The elevator was a gateway to a new era. It was more than technology, it was a revolution. That's why the dream was so powerful. Turning the space elevator from fiction to reality required careful, incremental progress. The discovery of carbon nanotubes in 1991, lightweight, incredibly strong, offered a potential solution to the material challenge. Suddenly, the impossible seemed within reach. NASA and other agencies began serious studies, breaking the project into manageable parts. Bradley Edwards led a major NASA study, identifying key technologies, ribbon material, climbers, and power beaming systems. His work showed that, while difficult, the laws of physics didn't forbid the elevator. Private groups and competitions, like the Space Elevator Games, spurred innovation in tethers and climbers. Students, hobbyists, and engineers joined the effort, testing ideas and building a community. Each small step brought the dream closer. The elevator's path was long, but progress was real. The journey to the stars was underway. The dream was now a project in motion. A working space elevator would transform our world. Access to space would be cheap and safe, launching satellites as easily as shipping cargo. Global communications, weather forecasting, and climate monitoring would improve dramatically. The elevator's top would serve as a launch point for missions to the Moon, Mars, and beyond, using minimal fuel. Colonizing the solar system would become a realistic goal. Space-based solar power stations could beam limitless clean energy to Earth, helping solve the energy crisis and fight climate change. The elevator would foster international cooperation, requiring a global effort to build and operate. Space would become part of our neighborhood, not a distant frontier. Humanity would take its next great leap, not for conquest, but for exploration and growth. The elevator would open a new era of science, industry, and opportunity. It would change how we see ourselves and our place in the universe. The frontier would finally be open. The dream is inspiring, but the challenges are immense. The biggest hurdle is the ribbon material. Carbon nanotubes are strong in theory, but we can't yet make flawless cables thousands of kilometers long. The space environment is harsh. Radiation, temperature swings, and space debris threaten the ribbon's integrity. Even tiny collisions could be catastrophic. Designing climbers and power systems is another major challenge. Robotic vehicles must climb for days, powered by lasers tracked perfectly from the ground. Protecting the ribbon from laser energy adds complexity. Then there are political and financial obstacles. The elevator would be the largest, most expensive project in history, requiring global cooperation. Who builds it? Who controls it? How is it used? These human challenges may be the hardest of all. Yet every great leap faces obstacles. The path is daunting but not impossible. The dream endures because the rewards are so great. And the journey has already begun. Despite the challenges, the dream of a space elevator persists because it speaks to something deep within us. We are explorers and builders, always seeking to cross new frontiers. The elevator is the most elegant bridge we've ever imagined to the stars. Research into new materials continues. Graphene, boron nitride nanotubes, diamond nanothreads. We're learning to track space debris and protect structures in orbit. Small-scale competitions prove the core concepts work. Each discovery keeps hope alive. The need for bold solutions like space-based solar power grows more urgent. The elevator is about more than adventure. It's about building a better future. It's a story of hope, cooperation, and human potential. The journey will be long and difficult, but as long as we look up and wonder, the dream will never die. The ladder to the heavens remains within our reach. Humanity has always looked up, dreaming of touching the stars and walking on other worlds. For millennia, the heavens were the realm of myths, forever beyond our reach. But we are explorers, problem solvers. What was impossible became a challenge. Our first steps to space were explosive, riding columns of fire to break free from Earth's gravity. Rockets carried us to the moon and sent probes to the edge of the solar system, but at great cost and risk. It's like crossing an ocean by cannon. Possible, but hardly sustainable. What if, instead of fighting gravity with fire, we could simply climb? Imagine a ribbon stretching from Earth through the clouds into the blackness of space, a celestial thread connecting us to the cosmos. This is the dream of the space elevator, a gentle, continuous journey to orbit. It's a shift from daring leaps to building a permanent bridge, a routine commute to space. More than an engineering project, it's a testament to our ambition and imagination. Building a space elevator would be the greatest construction project in human history. It would push the boundaries of science, materials, and global cooperation. A modern wonder, serving all of humanity. Our stairway to the stars, built not by gods, but by us. The journey will be long and difficult, but the destination is the cosmos itself. The space elevator is not just a structure, it's a symbol of our future. It represents the next step in our evolution as a spacefaring species. The impossible is just a challenge waiting for a solution. We are ready to build our path to the stars. The dream is no longer fantasy. It's a blueprint for tomorrow. The stairway awaits. So, what exactly is a space elevator? Picture a vertical railway to the stars. At its core is an ultra-strong thin ribbon anchored to a floating platform at the equator, stretching over 100,000 kilometers into space. Robotic climbers would ascend this ribbon, powered by electricity. No rockets, no explosions. At the top, a massive counterweight, perhaps a space station or asteroid, keeps the cable taut, balanced by Earth's gravity and centrifugal force. The system is a cosmic tug-of-war, with the ribbon as the rope. Most journeys would end at a station in geostationary orbit, 35,686 kilometers up, where satellites appear motionless in the sky. Arriving here means you're already in stable orbit, ready to travel to the moon, Mars, or beyond, with minimal energy. The elevator transforms space access from a rare event to a routine journey. It's not just a lift, it's a gateway to the solar system. The space elevator would revolutionize how we reach space. It's a bridge between Earth and the cosmos. The dream is simple, but the impact is profound. This is the future of space travel. The elevator is our new launch pad. The idea of reaching the heavens is ancient, but the scientific concept of a space elevator began with visionaries. In 1895, Konstantin Tsiolkovsky imagined a tower reaching into space, inspired by the Eiffel Tower. He understood the physics, but the materials didn't exist. His tower would collapse under its own weight. The idea waited for technology to catch up. In 1959, Yuri Artsutinov proposed building the elevator from the top down, a satellite in geostationary orbit lowering a cable to Earth, balanced by a counterweight. This elegant solution shifted the concept from compression to tension. A cable, not a tower. Science fiction brought the idea to life. Arthur C. Clarke's The Fountains of Paradise made the space elevator feel real and attainable. Clarke's vision inspired scientists and the public alike. The dream moved from myth to engineering challenge. The space elevator became a symbol of what's possible. It's an idea waiting for the right materials and the will to build. The question is no longer if, but when. Building the elevator starts in space, not on Earth. A seed satellite is placed in geostationary orbit above the equator, likely anchored to a mobile ocean platform. From the satellite, a pilot ribbon is carefully unfurled toward Earth, while a counterweight is deployed outward to maintain balance. Once the ribbon reaches the ground, it's anchored securely. Robotic climbers then ascend, adding more material and strengthening the ribbon with each pass. The cable grows from a thread to a mighty structure, capable of supporting immense loads. After years of robotic construction, the ribbon is ready for its first human passengers. The stairway to the stars is open. The biggest challenge is the ribbon itself. It must be stronger than anything we've ever made. Steel can't support its own weight for more than a few kilometers. The elevator's cable must stretch 100,000 kilometers. The ribbon faces constant stress, vibrations, and threats from space debris and radiation. Active damping systems and resilient designs are essential to prevent catastrophic failure. The project's scale is immense, trillions in cost, decades of work, and global cooperation. It's not just an engineering feat but a test of international collaboration. The elevator is a world-building project, demanding new materials, technologies, and alliances. Every challenge is a chance to innovate. The impossible becomes possible, one breakthrough at a time. This is the ultimate test of human ingenuity. Imagine boarding the elevator at a tranquil ocean terminal, not a roaring launch pad. You enter a pressurized climber, more trained than spaceship, and begin a smooth, gentle ascent. The sky shifts from blue to black as you rise through the atmosphere, the earth shrinking below. The journey takes days, not minutes, but it's comfortable. Living quarters, observation decks, and breathtaking views. You watch the world transform into a blue marble, witness dozens of sunrises, and see satellites drift by. After about a week you arrive at the geostationary station, weightless, in stable orbit. From here the solar system is within reach. Travel to the moon or Mars now requires a fraction of the fuel. The elevator turns space travel into a scenic voyage, not a test of endurance. The journey up is just the beginning. The space elevator depends on a miracle material, something with immense tensile strength and low weight. Steel, titanium, even Kevlar fall short. The breakthrough came with carbon nanotubes, tiny cylinders of carbon atoms, stronger than steel and lighter than plastic. A ribbon, woven from nanotubes, could finally make the elevator possible. But making a flawless 100,000-kilometer cable is a monumental challenge. We've only made nanotubes a few centimeters long. Scaling up is the next frontier. Other contenders like graphene and diamond nanothreads are being explored. The race is on to perfect and mass-produce these materials. The elevator is now an engineering problem, not just a fantasy. The future hangs by a thread, one we're learning to weave. Imagine waking up to see a shimmering line stretching into the sky. The space elevator, real at last. The first ride is a global event, symbolizing a new era of access, not conquest. Once operational, the elevator slashes the cost of reaching orbit, making space accessible to all. Satellite networks expand, bringing global internet and clean energy from space-based solar stations. Manufacturing in orbit creates new materials and medicines, while asteroid mining becomes viable. Space becomes a place to work and live, not just visit. Tourism flourishes, hotels in orbit, honeymoons on the moon. Scientific research accelerates, with giant telescopes peering into the universe's origins. The elevator integrates space into our economy and culture. It's a conduit for industry, discovery, and imagination. The world is transformed, even for those who never leave the ground. The elevator is more than a structure, it's a revolution. Our future is no longer earthbound. The first space elevator marks a turning point. We become an interplanetary species. Cheap, reliable access to orbit makes permanent human presence in the solar system possible. Like the railways and ships of old, the elevator opens new frontiers and connects worlds. It's the artery pumping life and resources into space, the foundation for a new civilization. Our dreams of exploring the universe are finally within reach. The elevator is the key that unlocks the cage of gravity. We can now plan for centuries, not just years. The universe calls us to explore, to wonder, to reach beyond. Rockets were our leaps. The elevator is our ladder. It's a symbol of hope and a promise to future generations. The endless frontier awaits. We are building the door. The stars are within our grasp. For centuries, humanity gazed at the night sky, dreaming of reaching the stars. We took our first steps with rockets, brave, explosive, and costly leaps to the moon. But these journeys were rare, dangerous, and expensive, like crossing a stormy ocean in a fragile boat. Now, imagine a ribbon, stretching from Earth into space. A space elevator. This is not science fiction. It's a real, permanent bridge to orbit. Instead of fighting gravity with rockets, we ascend quietly in a climber, watching the world fall away beneath us. The space elevator is a revolution, a cosmic ladder that changes everything. The idea has been around for over a century, but only now with carbon nanotube composites has it become reality. On January 15, 2026, the first great space elevator, anchored in the Pacific and reaching geostationary orbit, opened the final frontier. It stands as a monument to human persistence, a shimmering thread connecting us to the cosmos. No longer are we just visitors to space, we are becoming residents. The elevator is not just transport, it's the key to a future where humanity is a true citizen of the solar system. We are no longer bound to Earth. The dream has become a blueprint, and now, a reality. The elevator is our umbilical cord to the stars. It represents a fundamental shift in our relationship with space. We are building a future, once only imagined. The space elevator is the door to that future. We are stepping through it. The stars are no longer out of reach. Our journey has just begun. To see why the space elevator is revolutionary, we must understand the old way. Rockets. The rocket equation, discovered by Tsiolkovsky, is unforgiving. To send a little to space, you need a lot of fuel. Rockets are mostly fuel, with only a tiny payload at the top. It's like using a lorry to deliver a single letter. All that fuel is burned in minutes just to escape gravity. Rocket launches are violent, wasteful, and risky. The cost was astronomical, hundreds of millions per launch, making space exclusive to governments and big corporations. Every mission was a gamble. Failure meant catastrophic loss. This high cost and risk slowed progress and kept space out of reach for most. Rockets were inherently dangerous, strapping people to controlled explosions. Astronauts risked their lives every launch. The environmental cost was high, with tons of exhaust released into the atmosphere. As we reached for space, we paid a price on Earth. The rocket era was glorious but unsustainable. We needed a safer, cheaper, and more accessible way. The rocket equation was a wall between us and the stars. The space elevator tears down that wall. It's a new chapter in our journey. The age of rockets is ending. The elevator is our path forward. How does the space elevator overcome the rocket equation? With elegant simplicity, it starts at a floating anchor in the Pacific, where a carbon nanotube ribbon stretches up to geostationary orbit, 35,786 kilometers above Earth. A massive counterweight at the top keeps the ribbon taut, like a guitar string held by Earth's spin. Climbers, electric vehicles, grip the ribbon and ascend, powered by energy beamed from the ground. No fuel is carried. The climber sheds the rocket's burden. The journey is slow and smooth, taking days, not minutes. The system is efficient. After the initial build, each trip costs little more than electricity. Climbers are reusable, making thousands of trips. It's the difference between building a new ship for every crossing and building a permanent bridge. The elevator is that bridge, our link to orbit. No more throwing away rockets, no more explosive launches, just a steady, graceful ascent. The elevator is our bridge to the cosmos. The future of space travel is here. The space elevator has slashed launch costs from $20,000 to under 200 pounds per kilogram. This 99% drop has democratized access to space. Universities, startups, and even small nations can now send satellites and experiments to orbit. Manufacturing in space is booming, with raw materials sent up cheaply and cleanly. Safety has also transformed. No more violent rocket launches. The elevator ride is smooth, with gentle acceleration, safe for all. Space travel is now open to ordinary people, not just elite astronauts. Space tourism is real, and working in orbit is a viable career. Scientists, engineers, and technicians can travel safely to orbital labs and factories. The elevator has made space a workplace, not just a destination. The economic and safety revolutions are changing everything. Space is no longer exclusive, it's accessible to all. The elevator has made living in space possible. With affordable, constant access, we've built true habitats in orbit. Sprawling communities, not just cramped stations. These towns in the sky have homes, farms, and recreation, designed for long-term life. People work, play, and raise families with Earth always in view. Rotating habitats create artificial gravity, solving health issues of zero-G. Children are now born in space, a new generation for whom Earth is a distant home. The elevator keeps these communities connected, with supplies and people flowing both ways. Isolation is gone. Orbital settlements feel like suburbs of Earth. we're not just visiting space, we're extending civilization into it. The high frontier is now a permanent home. Humanity is expanding beyond Earth. The future is in orbit. The elevator's impact reaches back to Earth. Cheap, easy satellite launches have created global high-speed internet, closing the digital divide. Earth-observing satellites now monitor weather, disasters, and resources in real time, saving lives and improving management. Millions of jobs have been created: engineers, technicians, logistics experts, and new industries supporting the space economy. Zero-gravity pharmaceuticals, space tourism, and advanced manufacturing are booming. But the biggest change is perspective. Millions have seen Earth from space, experiencing the overview effect, a sense of unity and responsibility for our planet. Borders vanish. The atmosphere looks fragile. This new view is changing our consciousness. We see ourselves as crewmates on Spaceship Earth. The elevator has connected us to the cosmos and to each other. Our world is transformed. The journey upward has changed us all. For science, the elevator is a revolution. Orbital labs free from gravity enable breakthroughs in biology and materials science. Perfect protein crystals and new alloys are now possible, leading to medical and industrial advances. Astronomy has entered a golden age, with giant telescopes in orbit peering deeper into the universe. We're imaging distant planets and witnessing the birth of galaxies. Industry has followed. Flawless fiber optics and pure silicon are made in space and sent down the elevator. Some heavy industry has moved off-planet, reducing pollution on Earth. The geostationary station is now a port, launching missions to the Moon, Mars, and beyond. With less gravity to fight, interplanetary travel is easier and cheaper. The elevator has made the solar system our backyard. Science and industry are unleashed. The next era of exploration has begun. Space is no longer just for astronauts or billionaires. The elevator has made trips to orbit as affordable as a luxury cruise. Teachers, artists, families, and students are now space travelers. Orbital hotels offer stunning views and zero-gravity adventures. Space tourism is booming, but so are new opportunities for work and education. Universities have orbital campuses. Tradespeople build and maintain space infrastructure. Space is a blue-collar and white-collar frontier. Artists, musicians, and filmmakers are creating in orbit, weaving space into our culture. Space is now part of everyday life, a place to live, work, learn, and create. The elevator has democratized the cosmos. Space is for everyone. Our shared human experience now includes the stars. The universe is open to all. The first space elevator is just the beginning. More elevators are being built worldwide, creating a highway system to the heavens. This will accelerate the growth of orbital cities and the space economy. Next, we'll build elevators on the moon, making lunar bases and resource mining routine. A lunar elevator will turn the moon into a hub for exploration and industry. The grandest vision, a Martian elevator, enabling safe, easy delivery of people and supplies to Mars. This technology could make us a multi-planetary species. The elevator has changed our destiny, untethering us from Earth. We stand at a turning point, like the first ocean explorers. The path to the stars is open. The elevator is a symbol of our limitless potential. The journey has just begun. The future is ours to build. Let's break down the space elevator, one of the most ambitious engineering concepts ever imagined. It's a vision that could change how we think about reaching space, making it as routine as catching a train or an elevator on Earth. Imagine reaching space not with a rocket, but with a lift. A cable stretching from Earth to the stars. Instead of a thunderous launch, you'd step into a cabin and begin a smooth, upward journey, watching the world shrink beneath you as you rise. This cable, made from ultra-strong carbon nanotubes, is anchored to a floating platform at the equator. These nanotubes are among the strongest materials known, able to withstand the immense forces involved. The floating platform itself is a marvel, designed to weather storms and ocean currents while holding the cable steady. The equator's spin keeps the ribbon stable, using Earth's rotation to our advantage. By placing the anchor here, the cable remains balanced and upright, thanks to the centrifugal force generated by our planet's constant turning. The other end? It extends over 100,000 kilometers into space, ending with a massive counterweight in geostationary orbit. This counterweight is crucial. It pulls the cable tight, keeping it from collapsing back to Earth, and ensures the entire structure remains balanced. This setup keeps the cable taut, balanced between gravity pulling down and centrifugal force pulling out. The tension is immense, but it's what allows the elevator to function, creating a stable path from the ground to space. Robotic climbers, powered by solar energy, ascend the ribbon, carrying people and cargo into orbit. These climbers are like futuristic trains, gliding smoothly up the cable, using advanced motors and drawing power from the sun with massive solar panels. The journey is calm and efficient. No fiery launches, just a steady electric hum. Passengers would experience a gradual transition from Earth's gravity to the weightlessness of space, all while enjoying breathtaking views of our planet below. It takes days, not minutes, to reach orbit, but the cost drops dramatically, by a factor of 100 or more. This means space could become accessible not just to astronauts, but to scientists, engineers, and even tourists. Rockets burn fuel for minutes. The elevator offers a permanent, energy-efficient highway to space. Instead of single-use launches, the elevator can operate continuously, moving cargo and people up and down with far less energy and environmental impact. Once built, it transforms space from a rare destination into a place we can visit, work, and live. Imagine research labs, factories, or even hotels in orbit, supplied and staffed by regular elevator trips. The elevator's genius is finesse, not brute force. It's about using the laws of physics and the strength of new materials to open a gentle, reliable path to the stars. It's a revolution in how we access the cosmos. The space elevator could spark a new era of exploration, industry, and discovery beyond Earth. Imagine sending satellites, telescopes, or even snacks to orbit for a fraction of today's cost. The possibilities are endless. New science, new businesses, and new adventures await. The space elevator isn't just a dream, it's a game-changer for humanity's future in space. It could make the impossible possible and bring the universe within our reach. It redefines our relationship with the stars, turning space from a distant frontier into a familiar destination. The sky is no longer the limit. With a space elevator, our ambitions can stretch as far as our imagination allows. It's the beginning of a new era, one where humanity's reach truly extends beyond Earth, and the journey to the stars becomes part of our everyday lives. Picture your morning commute. Now imagine it unfolding not along crowded highways or packed subway cars, but vertically, rising gently through the clouds. The world you know shrinks beneath your feet as you ascend, and the horizon stretches out in every direction, painted with the blue curve of Earth. The space elevator becomes as routine as a train ride, yet infinitely more breathtaking. Each journey is a blend of the familiar and the extraordinary, commuters reading the news, sipping coffee, or chatting with friends, all while floating above the world. Students take field trips to orbital stations, gazing down at Earth as part of their lesson. Geography and science come alive as they witness continents, oceans, and weather systems from a vantage point once reserved for astronauts. Workers, miners, technicians, hotel staff ride the climber to jobs in orbit or beyond. Their daily commute now means crossing the boundary between Earth and space, bringing new meaning to the phrase, working remotely. Families visit grandparents in low-orbit communities, turning the journey into a shared adventure. Birthdays, reunions, and holidays are celebrated with the planet as a backdrop, creating memories that span generations and worlds. Kids press their faces to the window, watching satellites drift by like distant ships. Each trip is a chance to spot something new. A passing spacecraft, a meteor shower, or the shimmering auroras dancing far below. The elevator makes space accessible, safe, and predictable. No launch windows, no G-forces, no roaring engines. Just a smooth, steady ascent where the extraordinary becomes part of everyday life. Meals, movies, and naps replace countdowns and turbulence. Travelers enjoy the comforts of home with entertainment, dining, and rest, all available as they glide toward the stars. Space travel becomes democratic, open to everyone, not just astronauts or billionaires. The elevator welcomes people of all ages and backgrounds, making the cosmos a place for all humanity. It's the railway of the cosmos, connecting Earth to the solar system. The elevator's cable is a lifeline, linking our blue planet to the vast frontier above. The map of human experience expands upwards. Each journey redraws the boundaries of what's possible, inspiring new dreams and ambitions. The elevator turns space into a destination for all, inviting us to step beyond our world and into a new era of exploration, connection, and wonder. At the base, a new city rises, Port Meridian. Built on the equator, it's a global crossroads, buzzing with engineers, tourists, and scientists. The city's design blends resilience with futuristic flair, built to support the elevator's operations. Schedules for climbers and cargo are the city's heartbeat. Industries thrive: zero-G manufacturing, space resource processing, and astronaut training. Museums and universities make Port Meridian a hub of culture and innovation. Life here is shaped by cosmic ambition. Children grow up seeing space as a reachable place. Port Meridian is the launchpad for humanity's next chapter. Ascend the elevator, and you enter orbital suburbs, spacious habitats, not cramped labs. Rotating sections create artificial gravity, making life comfortable and healthy. Windows offer views of continents drifting by. Kids learn zero-G sports. Everyone's trained for safety. These communities are tight-knit, blending the extraordinary with the everyday. Industry thrives: perfect crystals, advanced alloys, and medical breakthroughs made possible by microgravity. Hospitals pioneer new treatments, factories produce materials impossible on Earth. At geosynchronous orbit, GEO-STED is a bustling hub: hotels, labs, shipyards, and more. From here, journeys to the Moon, Mars, and beyond begin. Humanity builds not just outposts, but lasting homes in space. The elevator sparks a job revolution, new-collar careers for a new era. Materials scientists and nano-engineers build and maintain the ribbon. Climber pilots, ascent coordinators, and maintenance techs keep the system running. Logistics managers orchestrate cargo and passenger flow. Zero-G chefs, hotel staff, and tour guides serve orbital visitors. Asteroid miners, space resource refiners, and debris specialists expand the economy. Millions find opportunity in the elevator's shadow, on Earth and in orbit. For science, the elevator is a dream come true. It slashes launch costs, enabling giant telescopes and vast space observatories. Instruments are assembled in orbit, opening new frontiers in astronomy. Probes to Mars and beyond launch from GEO-STED, using Earth's spin as a slingshot. Sample return missions and permanent outposts become routine. The elevator is a vertical laboratory, packed with sensors to study Earth's atmosphere in detail. We monitor climate, weather, and chemistry like never before. The universe, and our own planet, are finally within reach. The elevator isn't just for exploration, it's a tool for planetary protection. Climate engineering becomes possible, sunshades in space to cool Earth if needed. Space-based solar power arrays beam clean energy down 24/7. The elevator's electric operation means near-zero carbon emissions. Fewer rockets mean less pollution in the upper atmosphere. It's a sustainable highway to space, helping us heal Earth as we reach for the stars. The elevator gives us the power and responsibility to shape our planet's future. But the elevator brings new challenges. Safety is paramount. Designs must handle ribbon breaks and protect against debris or sabotage. Ownership and control raise geopolitical questions. Who runs the gateway to space? Economic and social divides could deepen. How do we share the benefits? Easy access to space could change how we value Earth's resources and environment. The elevator's impact depends on our wisdom and foresight. We stand on the edge of a future once imagined only in science fiction. Today, the dreams of visionaries and storytellers are becoming tangible as humanity prepares to take its next great leap. The world around us is changing faster than ever, and the boundaries that once held us back are dissolving before our eyes. The space elevator is a bridge to the cosmos, transforming space into our backyard. No longer will space travel be reserved for a select few. This innovation opens the door for everyone to reach beyond our planet. It's a marvel of engineering, stretching from the ground to the stars, connecting Earth to the infinite possibilities above. For future generations, the sky is a destination, not a limit. Children will grow up dreaming not just of flying, but of traveling to the stars, of exploring new worlds, and of building a future among the planets. The universe will become their playground, and their ambitions will know no bounds. The ribbon becomes a symbol of possibility, a silver thread to the stars. It represents hope, ingenuity, and the unbreakable human spirit. Every meter of its length is a testament to our determination to reach higher, to connect with the unknown, and to turn imagination into reality. The journey to orbit is a rite of passage, a leap for all humankind. Each ascent is a celebration of our progress, a moment when ordinary people become pioneers, and the impossible becomes routine. The elevator will carry not just cargo but dreams, hopes, and the promise of a brighter tomorrow. The challenges are real, but the rewards are immeasurable. Building this structure will test our creativity, our resolve, and our ability to work together. Yet every obstacle overcome brings us closer to a future where space is within everyone's reach. It's an investment in our species' future, demanding global cooperation. Nations, scientists, and dreamers must unite, sharing knowledge and resources to achieve what no one country could do alone. This is a project that belongs to all of humanity. Imagine that shimmering line on the horizon, our highway to the stars. It's a beacon of hope, a promise that the future is bright, and that our greatest adventures are still ahead of us. The elevator is about moving forward, together. It's about unity, progress, and the belief that when we join forces, there's nothing we can't achieve. Your ticket to the stars is waiting. The question is not if, but when do we start building? The future is calling, and it's time to answer.